Good morning, John. We just got the first images from the James Webb Space Telescope, and a lot of people, it seems, are feeling a bit small right now. Maybe humbled, maybe insignificant. But here's something weird. I'm actually not sure if I feel very small right now or very big. So when you look at a structure like the cosmic cliffs with 7 light-year tall peaks, or a deep field image that you cannot put your pinky finger on without covering several galaxies, it makes sense to think, okay, so why do we think that anything that happens here on Earth matters at all? And there are really good human answers to that question. Answers like, we give our universe meaning. We matter to each other. But there are also maybe some kinda objective answers. Would we understand that an area in the sky the size of a grain of sand contains thousands of galaxies that each contain billions of stars, and we say, I feel insignificant now? That is not a way of saying nothing matters. It's an instinct that something matters, but that mattering is spread throughout what appears to be a basically infinite universe, and so we don't matter. Something matters, just not us, because we are too small to matter. But I wonder, is size the right measure? I've got a kinda okay understanding of how the universe works. Not great, but maybe a bit better than average. And one thing that seems to be basically the case is that there are a bunch of practically infinite fields that cause particles to exist and interact in a number of ways, and as evidenced by the presence of oxygen and hydrogen spectra in galaxies billions of light years away, the rules appear to be consistent throughout the whole universe. Now, this is all very complicated, but it's also not. It's just physics doing physics things. But while the universe is astoundingly big, indeed very possibly infinite in size, it's not that big in time. Now, you might say, Hank, actually 13.7 billion years seems like a very long time, like practically infinite. But no, the universe is young compared to both infinity and compared to its eventual lifespan. Life on Earth is one continual chemical system that dates back 3.7 billion years, which means that this wild frolic that includes everything from brachiosaurs to BTS has existed for 27% of the lifetime of the universe. We do not take up much space, but we have taken up a lot of time. So that's one way we are bigger than we might think, but here's another. The vast majority of the particles in the universe do not know they exist. They have never wanted something. They've never looked at something and found it beautiful. They have never built a space telescope. And when I say vast majority, I mean that the number of particles that are part of any system with wants and sensations is so small that they may as well be ignored. But we can agree they should not be ignored because they are very strange and very different and very beautiful, and they know things about themselves and about each other. In your head, you have around the same number of neurons as there are stars in the Milky Way galaxy. And those neurons are much smaller than stars, but they are in fact more ordered, and you could argue that each one is more complex. If you think galaxies are amazing, just wait until you find out about you. Now, are we the only chemical system to have built a space telescope? No. The way I understand the universe, that is an impossibility, but it also does not seem very common for the universe to find paths toward waking up. And to be a part of that, it feels very big. John, I'll see you on Tuesday.